All right, looks like we can start. Hello, everyone. My name is Sofia. Today I'm going to talk to you about GitHub Actions, a cloudy day for security. Now, whether or not it's actually a cloudy day is up for debate. I just wanted a title mentioning GitHub Actions and the cloud and the pun, so here we are. All right, if you want to follow along, the slides can be downloaded at this link. I'm not trying to hack your issue. I mean, do this at your own risk. I work at a company called NDC Security, where I work as a pen tester, which I've been doing for a couple of years. So what I'm going to talk to you about today, this is a very detailed outline. There's going to be two halves in the talk. For the first half, I'll be focusing purely on GitHub CI/CD security, so by that I mean GitHub Actions. And often in this type of talks, one hears about what can you do when there's like a public repository, what can I do as a random person on the internet? For this talk, we'll actually mostly focus on the case where you have, let's say, a private repository, and I am someone with write permissions to that repository, so Collaborator, that's called in GitHub. So this is kind of emulating the case of you have a big organization and one of your developer accounts, let's say, is compromised. What can we do then? Or you are a big organization and you automatically give all your employees write access to all your GitHub repositories. You compromise some random account. What can we do? Then for the second half, we'll move it up into the cloud. We'll talk about federated identities, or workload identities, or identity federation, or whatever it's called in the different cloud providers. And really, that's just OIDC. If you don't know what that is, we'll talk about it later. So I'll mention the three major cloud providers and how stuff is done, Azure, GCP, and AWS. As a little disclaimer, I should say that 95% of our customers, when I do pen tests, use Azure, so that's by far the one I know the best. We do a little bit of the others too. I'll try to cover them, but if I say something completely ridiculous, that's on me. Okay, as we go along, I'll be giving examples of vulnerabilities we find in customer assessments. And you'll notice pretty quickly that all of these vulnerabilities are from the same class of vulnerabilities, which is misconfigurations. Okay, so perhaps unsurprising, you start with GitHub Actions, a massively complicated system with a bunch of config. You have some cloud provider, probably even more complicated with even more config. You try to integrate the two of them. There's 200 million things you can do wrong, and we end up with misconfigurations, which are security vulnerabilities. Okay, let's start with saying what GitHub Actions are. So this blob is taken from the documentation. Really what GitHub Actions is the automation bit in GitHub. That's how I think of it. So if you want to automate running tests, deploying, and building, that type of stuff. GitHub Actions runs through something called a workload. That's the key entity going on in a GitHub action. And a workload is really just a YAML file which you check out to your repository. So this is an example of such a workload. You're going to see how the text is. I don't know if you guys can read. I guess you can come closer if you can't read. So this is an example of just doing some kind of Python stuff in my repository. This is junk. I've written it, so it's probably not even right. You can see here on line number 1, we have a name. On lines number 3 and 4, we have this special on keyword. And that defines when is this workflow going to run. So throughout the talk, you'll see stuff like whenever someone pushes to a specific branch, I want my workflow to trigger. Whenever someone opens a pull request to a specific branch, I want my workflow to trigger. Or here we have this magic workflow dispatch keyword, which means just give me a button so I can run the workflow on demand, which is easy for testing. And then starting from line 8 onwards, you have the actual steps. What is this workflow going to do? And this is in many ways just code execution. This is a script just doing stuff for you, except we are a bit fancier than just writing all the code ourselves. We can call out to predefined actions, stuff which other people have set up for me. Yeah, so for example here, I call out to someone else's action to set up Python and check out the code repository, etc., etc. It doesn't matter if you don't understand what any of the actual Python stuff is doing. That's completely irrelevant. Then you have a view in your repository. You can go to an actions tab. You get a list of the actions which have been running. You get a green or a red mark depending on if they succeeded. You can see what different workflows are defined. You can click the run workflow button to run one, which has this workflow dispatch thingy. You can click into a workflow which has run and see the logs. Here's the example of me running Python type checking on a repository which has a hello world file in Python. I did it, no issues. So that's what GitHub Actions are. You'll see more examples of these as we go, so hopefully that will, you'll get used to that. We need to talk a little bit about the GitHub security model, because otherwise we can't do security. So at a kind of like overarching level, there's 3 permissions in a repository I'm going to care about. This is not true. There's a bunch more roles you can assign, and you can do more fine-grained stuff as well. But the ones one sees realistically is someone with read permissions to a repository, someone with write permissions, which is referred to as a collaborator, and someone who is either the owner of a repository or has been given administrator role on the repository. Then there's some things you can and can't do as these different roles. This entirely chaotic slide is attempting to have things you may do on one side and may not do on another side. So as a reader, there are some things you can do. You can read code, it's kind of in the name. You're also allowed to do stuff like submit issues. So imagine a case where you have someone who's like in touch with customers and they report a bug. You want to go in and like report an issue for the bug into the repository, even though I'm not going to write the code to fix it. As a reader, I'm not supposed to do anything which a write person can do, so I shouldn't be allowed to commit code, create branches, a bunch of other stuff. If you are a collaborator, so a person who can write, you obviously have to be able to commit code. That's kind of your job at this point. Create branches. And also, and this is kind of key throughout the talk, you have to be able to modify these workflows. So I said initially that the workflows are just YAML files checked out to the repository in question. So since I can modify the code in the repository, I can also modify these files. And that makes sense that you have to be able to do as a developer in order to be able to do anything, because like if I'm changing some test setup or something, I have to update the corresponding workflow to run the appropriate tests, right? However, even though I can write code and stuff, there are several things I'm not allowed to do as a collaborator. So one thing is that, at least I feel that if a single developer should not be able to deploy code directly to production without any other approvals. So that's protecting against the case, again, where you have a single compromised developer account. There should be some kind of like defense in depth here, so you can't just go straight, right, push my malicious code to production, run it, let's go, I've taken over everything, right? In addition, there's no reason why your developers should be able to view production-level secrets. So someone obviously will have to have set up your secrets, but you don't want to share them with everyone. That's kind of part of this whole like modern CI/CD flow, is that you don't want to have a bunch of hard-coded secrets you pass around, and I copy-paste your like password to SSH to some server and manually copy. Like, we aren't doing this. It's supposed to be automated, and as a regular developer, I should never need to see the production secret stuff. On a similar note, let's say we are integrating with a cloud environment. Just because I have write permissions on a repository, I should obviously not suddenly get lots of permissions in your cloud provider. Like that's a ridiculous thing to happen, but that does in fact happen, as we'll see. Then we have the admins. They can do everything. If someone compromises an admin account, you're screwed. We won't talk more about them. Okay, I did say I'd focus mainly on collaborators, but I'll speak first about one vulnerability class, which is also relevant for people with read permissions, and that is script injection. So as a person with read permissions, I can't modify code, and therefore I can't modify workflows. So it's not like I can just go and change the code which is running. However, sometimes user-controllable values make their way into the workflow anyway, and I can somehow inject some malicious code. So there's actually a warning about this on the GitHub documentation. That's what this blob is taken from. And it's related to something called the GitHub workflow contexts. So these context thingies, what they are is really just this funny dollar curly bracket syntax, which you can see on this slide. So there's like dollar thingy, and then inside that there's some magic thing, which GitHub is going to go and replace with a real value when I execute the workflow. So in this case, we have github.actor. That's just going to be the username of the person who initiated the run of this workflow or triggered the workflow to run. So in this case, it was me. And then you see it prints that Sofia ML is testing instead of dollar thingy is testing. OK, so that's fairly straightforward. Let's do a little demo to wake up. Let's see if I manage this. Exciting times. All right, now, we probably can't see the text very well, so I'll zoom a bit. Let's see if I manage this. We have a workflow defined here, which is basically the same as I had on my first example slide. But now we've made it so it triggers when you run a pull request. And then here at the top, I've been a clever developer and said, ooh, when you read these logs, it would be really handy if you can like print the title of the pull request so I know what's going on here. So I've added on line 10 here, running Python stuff on pull request with title, and then I use one of these GitHub context thingies to get the pull request title. Okay, let's watch me slowly mousing over things. We'll zoom. Let's see. So here's an example of a run. You just see that has been replaced by some real value. Also, I'm doing this as a person with read permissions, so I was not allowed to edit the code directly. But what I can do is I can go and make a pull request, which is what's happening here. We'll pause there. So I'm making a pull request as a reader. So this is perhaps surprising to some people, even though I can't make any code or make any branches. If someone else has made some code and a branch for me, I can make the pull request. And I'm now in control of the title. So here I've just inserted a payload, which is like reaching out to my server. It's not doing anything special, it's just doing a call command. So let's zoom out and let that keep playing. I create the pull request. This should now trigger the run of the action. So this takes a few moments. There we go. This is also what GitHub Actions look like in action. We have to wait a bit. It starts doing stuff, and we can see something which looks like a curl command running up there at the top. And the thing finishes. We go to my server. We see we've got a request, and let me pause that and see if I can show you again. So the request which I received on my server was exactly the one I defined in the GitHub pull request title. Okay, I think that was the end of that one. So back to the slides. What actually happened here? So here's another example of script injection. In this workflow, I've set it to trigger whenever someone creates an issue. Now, let's say I want to make a workflow which automates, like, whenever a new issue is submitted, I want to tag it based on some keyword search or something. Again, I'm being a helpful developer, so I'm going to print the title of the issue initially so that you guys know what's going on when you read the logs. I'm using the GitHub context again. A reader can submit an issue. They can use $ID as the title, let's say. And what happens when this runs is that, again, instead of getting new issue $ID printed, you get the output of the ID command in Linux. The reason why this is happening is that GitHub performs the replacement of the context thingy before you ever get to running any code. So when we've gotten to bash, the code you can see is actually this extra line I've written underneath, and that's exactly what has executed. So no amount of quoting and things inside your bash script are going to protect you against this, because the replacement is happening at the earlier stage, right? So if you put lots of quotes and stuff, I can just escape them again within my injected code. Luckily for us, there is a fix for this, otherwise GitHub Actions would be awfully vulnerable, and that is to use this env keyword in your step. So you can see on lines 9 and 10 here, I'm setting up the environment for the command which is being run in this step. Here I'm defining an environment variable named title, which has this value. And then you can see the bash code on line 12 here, in this case, is safe, right? Even if you have lots of funky stuff inside the $title environment variable, the way bash works, this isn't going to give you any sort of injection. You can still mess up your bash, of course, but assuming you have proper bash, this isn't going to be vulnerable. We try the same attack again, and this time it prints what we expect. OK, so I made this wonderful graphic. I searched for warning, and I put that symbol. So this is telling you, if you want to use GitHub contexts, you should be using the env key. OK, we can go on a lengthy debate here about, like, yeah, but not all of these context things are user controllable, right? Like, maybe you have the, I don't know, the hash of your commit. That's not, you can't inject into that. And it's like, that's true, but also it's just much easier to just always use env, and then you're never vulnerable. So I recommend doing that. All right, from now on, we, the hackers, are going to be collaborators. So we have write access to everything from now on. We are first going to ask ourselves a really dumb question here, which is, let's say our repository is set up in such a way that we are going to deploy code from the main branch to production. Main is like the source of truth. I'm a collaborator, I have write permissions. Can I not just push any code I want to the main branch and then I've owned production? Like, isn't this whole exercise a bit pointless with write permissions? If you've used GitHub at all, you probably will have seen this before, which is you can set up branch protections. OK, so not anyone should be able to push to your main branch. Actually, it's not called branch protections anymore. It's called rule sets, but you'll end up in the right place in the settings. So what that is that for one or more branches, you can set up a bunch of protections, so things which have to be satisfied when interacting with this branch. And one of the main things here, which I recommend using, is to require that in order to get code onto this branch, you have to go via a pull request. Okay, so I can't push directly to main. I have to open a pull request, and then it comes in via the pull request. You can also add a bunch of extra requirements on this pull request, so you can specify how many approvals it needs. So by default, GitHub does not let you approve your own pull request. That's good. Also, as a reader, you are allowed to approve pull requests. Again, readers can do all kinds of funny things, but that does not count towards this counter. So that's not an attack. It needs to be ex-collaborators who approve. Typically, you'll want one approval, but maybe you have a really special case where you need 2 different people to look at this. You can configure that. Okay, then there's a bunch of stupid things I can do. So let's say I make a pull request with legitimate code. I fix a bug. The person who reviews it is really happy and says, yes, go, get in the bug fix. After they've approved, I push my malicious code, and then I merge because my pull request was approved. That's a pretty obvious attack. There's a protection against it, which is to say you have to have approved the most recent commit. This is kind of annoying, actually, when developing, because like, you make a small change, you reset the approval status. There is a reason for doing this, though. Another thing I can do is I can see that like, some other guy has made a pull request. I'm allowed to approve it, because it's not my pull request, but I'm also allowed to push code to his branch, right? So maybe I go in on an existing pull request, I push code to that branch, I approve it, now my code is in. There's a protection for that as well, which is to say that the approval must be by someone else than whoever pushed the last code. So by me pushing code to this branch, I've now kind of removed myself as a valid approver for this pull request. And finally, you can, if you want even more restrictions here on who's supposed to approve your pull requests, you can require that the approval must come from someone in your code owners file. So by default, it will be anyone with write permissions can make one of these approvals, which counts. If you want to restrict it further, this is one way to do it. Okay, we've learned we can protect our main branch. Let's assume we've done that and been good developers. Here I have some really, really sensitive workflow. And I've set up here that the only time it runs is when you push code to the main branch. I've just configured it so the only way you get code to my main branch is via my like extensive pull request system, so you can't just sneak in the code. This is good. This is, of course, not good because collaborators can change the workflow file, right? And if you think about it a bit, the way this has to work is that the workflow which runs is the workflow version on the branch you are currently running, because anything else would just become, I guess, less usable. I don't know. I suppose you could do that, but you don't do that anyway. So what I can do as a hacker is I can make a push to my secret hacker branch where I modify this workflow to say, actually, trigger whenever I push to secret hacker branch. As I make this push, GitHub sees that on this branch, this workflow is supposed to trigger, and it runs in the context of my branch. Okay, so another big warning. Collaborators are in control of the workflow file that runs. A corollary of that is you cannot make security protections against the collaborator within the workflow file itself. They can just edit it out, right? You can put a bunch of checks. I just take away all that in my push, my commit. Next, we'll talk a bit about secrets. So there are 3 different ways to store secrets in GitHub, or at least 3. You can store them at the organization level, the repository level, or at the environment level. The organization and repository level are kind of similar, so I'll just pretend like the organization thing doesn't exist and talk about repository level first. So the way this works is that an admin, or someone with appropriate permissions, goes in the settings, goes to secrets, and sets up some secrets. So they have a name, and then they have a secret value. Pretty self-explanatory. The way to use them in a workflow is to use another one of these GitHub workflow contexts. So there's a special object called secrets, and then you just access the secret by name. So here, for example, I mean, this is, again, complete nonsense code. I've written it. It's not doing anything wise. It's trying to SSH to some production server and copy some files. Okay, but we've just learned that the collaborators are in control of the workflow file. So as a collaborator, I can go and make a new workflow or modify an existing one to do what is happening on the left here, which is echo all the secrets. So a nice little trick here at the bottom. In the GitHub context, you can use this toJSON thingy to make the secrets object into something you can read. I'm also base 64 encoding the output here. The reason for that is that actually GitHub Actions itself is trying to help you to not accidentally leak secrets. So it will sense it whenever you print the secrets in plain text. which you can actually see in the light blue text there. It has censored the result of the echo command itself, but then it has given me the base64 encoded output. If it tries to censor the base64 encoded output, which it does sometimes, you just base64 encode once more. Just keep doing it. At some point, you'll get it. Or do something more smart, like exfiltrate this in a safe way to a server. But this is demos at a talk. OK, so repository-level secrets can be read by collaborators. So if something actually is supposed to be secret, like restricted beyond your collaborators, you can't use repository-level secrets. I mean, you can, but it's not secure. Next, we need to talk about environments. So in the context of GitHub Actions, an environment is like, think like production, dev, test, staging, acceptance, whatever the latest and greatest names are. And the way this works with workflows is that a workflow may run in the context of a specific environment. So you specify this, like on line 15 here, where you have this environment key, which just give me the name of the environment I'm going to run in. In this example workflow, I've taken the name of the environment as an input, so you can like choose which environment you want to run in. And then what's so nice about this is that you have the secrets we just spoke about. They can also be configured at the environment level. So I can have one secret in the prod environment and one in the dev environment. You can also define variables per environment. So that's just things which vary, right, across environment. And then you can have a single deploy workflow. And depending on if it's running in the production environment or the developer environment, it's going to end up like deploying the code to different places. So here, that's just a workflow which prints the name of the environment. So that's not all that interesting. OK, so here is the red text is an example of, again, an attempt at having a safe prod environment. So here I have a workflow where I'm doing a check. If you're running on the main branch, you can run in production. If not, run in dev. We've seen this a bunch of times already. You can modify this as the collaborator, and I can just say that, nah, I'm running in production environment, actually. And then I steal all your secrets or something like that. There are no inherent protections in the environment. Okay? So it feels kind of safe and cozy. You say you're running in production. That has some checks and balances. It does not unless you set it up. Luckily, that's pretty simple. What you do is you configure your environment to only run on certain branches. So I say that the production environment may only run if your code is on the main branch. I also have branch protections on the main branch, otherwise this is pointless. So the combination of a protected main branch, production environment which can only run on the main branch, now this production environment is actually fairly locked down. You can also optionally, if you have some really sensitive workflows, you can require, sensitive environments, you can require explicit review for the running of the workflow. So then I'd like request, please run deploy to production. And then the people I've selected as possible reviewers here will have to go in and manually say, yep, that deploys OK, go for it. Cool. So if you've set your secrets up in the environment instead of the repository, and I go in and do my trick from a few slides back, where I'm just going to print all the secrets, then what will happen is the workflow run will fail if I'm not on the main branch, and it will say that the hacker branch is not allowed to deploy to production due to environment protection rules. OK, so that actually works. So let's say we now are following all the best practices. So we have branch protection set up on, let's say, a main branch. We have an environment set up, which is scoped to a protected branch. So now the environment is protected. And we have all our secrets set up at the environment level, so the secrets are protected. The problem here, of course, is, or it doesn't need to be a problem, but I feel like the modern philosophy is that like hard-coded, long-lived credentials are a bad idea because eventually they will get leaked. I have tried to illustrate this security concept in Paint. Long-lived static credentials, not good. Luckily for us, there's something more modern. Modern is maybe not the right word. There's something else we can do. We're going to the cloud. I Googled cloud. Right, we're going to talk about federated identities and OIDC. First, let me tell you what OIDC is. So there have been a bunch of talks already in this conference, I think, mentioning OIDC, so that's good. Then you guys already kind of know what it's about, and they have probably gone more in depth than I will now. It's a protocol, OpenID Connect. The like very dumbed down version of this is that it is a passwordless authentication protocol, which is based on OAuth. And the like key part which we need to care about here is that I'm trying to authenticate somewhere, And instead of me giving them a password, we instead go to a third party called an identity provider. I authenticate to them, and then we send an identity token back. So for example, on this login screen, I log in as Google. Google checks that I'm me, and then Google sends a token back. And this website can be like, yeah, I trust Google. Don't care what that person is up to, but Google has said they are this person. I'm going to go with that. The way this looks in GitHub Actions or workflows, I have a workflow which now wants to access a cloud resource because we are deploying, for example, to the cloud. GitHub is now going to be the identity provider because GitHub, or GitHub Actions I should technically say, knows everything about your workflow and like who's running it, what it's doing, etc. So GitHub sends an ID token to your cloud provider. I mean, the workflow is doing this, but yes, it comes from GitHub. The cloud provider trusts GitHub and is like, yep, signed by GitHub. I believe whatever says in this ID token. They check what kind of workflow is this. They go and check what you've configured that this type of identity is allowed to do, and then based on that, you get an access token back, which you then can do stuff with in the workflow. So like, for example, in the case of Azure, you could run the Azure CLI type thing. Okay, so that is like the super dumb version of this. We don't really need more details, though, to be able to continue. Here's as a side note, if you ever want to print what your identity token is, you can use something like the following. Here is an example identity token from GitHub. You may have noticed that it was bigger than the screen. This was on purpose, because it's long and we don't actually need more than the second claim. So the identity token is actually just a JSON web token. This is the payload part, and it has a bunch of claims, and the most interesting one for this talk is the subclaim. And here's an example of a value. So we're going to talk a bit more about this subclaim and how this is set up by GitHub. We're going to do this by example because the general case is so ugly to spell out. So when I run a workflow with default config in GitHub, if my workflow is running in a specific environment, then the subclaim in my ID token from GitHub is going to look something like the first one there, where you have a repo, colon, and then you have like the organization / name of repository, and then you have another colon, and then environment, colon, and then name of environment. So fill in the right repo and environment here, but that's the like general form of the subclaim. If you're not running in an environment, so that one takes precedence, but your workflow was triggered by some pull request related event, then instead you'll get the second one here. So you have the repo again at the start, and then instead of the environment at the end, you get just this pull request string. And then finally, if you are not running in the context of an environment, and you are also not triggered by a pull request, then it will look like the third one, where instead of the environment or pull request, we get a ref. So in this case, this is running from the main branch. This could also be a tag, but I like to pretend that tags don't exist, so let's say branch for now. So you get like the repo and then the branch. These are just strings. There's no structure to this. I mean, there are these colons, but it is just a string value we are looking at here. Okay, what I'm going to do now is I'm going to briefly talk about how to set up that your GitHub workflow can access your cloud provider for GCP, Azure, and AWS. We'll start with GCP, where this is called Workload Identity Federation, because it's important that each provider has a subtly different name for this, which is like almost the same, but not quite, so then you sound stupid when you use the wrong one when you're talking to someone who knows one of the providers well. GCP, I found, is the most complicated one to configure. Your mileage may vary. This might just be that I'm not that good at GCP. What you do is you start by setting up something called a workload identity pool. And in your pool, you can configure providers. So here's an example where I've started configuring a provider for GitHub. So I have to fill in like various other claims which are asserted on, which I'll never talk about again. Then you're forced to do something which is called to set up an attribute mapping. You're probably wondering what the hell is going on here if you haven't done this before. We consult the documentation, and if you don't want to understand everything you're doing, it tells you just set this equal to assertion.sub. And what you're configuring here is actually just what's like the main claim I'm going to be checking when I do checks on identities from GitHub. So what I've configured here is that it's the subclaim, the one we were just looking at, is the thing GCP is going to be checking. And that's what the documentation recommends, so I assume that means that's what 99% of people do as well. All right, now I want to grant access to this identity from GitHub to some resource in GCP. I've configured my provider. There's two ways to do this. There's the recommended way, which is fairly new. I think it was introduced in like last year sometime, which is direct resource access. So I go to my resource in GCP, let's say a virtual machine. I want to grant permission to a specific workflow coming from GitHub. And the way I do is that I grant it to an identity coming from a specific provider with a specific subject. So that's the subclaim. So I say, anyone coming from GitHub, which has a subclaim equal to this value, so here it's equality we check on, is allowed to access this resource. So this is like match on a string, literally, and you write the string, and then you do a match. Or the old way is that you instead impersonate a service account. So what you do then is that you say, any identity with a specific subclaim, so the same as before, can impersonate this service account and then can do everything this service account can do. So you give the permissions to the service account instead. This last one here has a very big potential pitfall, which is in one of your pools, where you made the provider, you can have any number of providers, and the service account is not tied to a provider, it's actually tied to the pool. So all your providers can use the same service account. So that's one thing to be aware of. Okay, that was a mouthful. Let's condense it down to the only bits I actually care about, which is when GCP is doing checks on the identity token from GitHub, I can assert on any value of any claim in the ID token. The docs recommend me to assert on the sub value. That's what I'm going to be doing. There's lots of ways to screw this up, but this is cloud agnostic, so we don't need to talk about it right now. Let's talk about Azure. In Azure, it's called federated identity credentials. Again, we need a different name everywhere. Okay, so in Azure, a federated credential is a credential, like access of some sort, which is associated with an Azure app, because we need more terms. What you do is you configure a subject identifier, which is again going to be the sub value in the credential. And then if a workflow presents you with an ID token with a sub that matches the exact string you've set up, then you may impersonate the app, which really is just Azure speak for saying you get access to a service principal, and then that is granted permissions again. In the UI, this is kind of dumbed down a lot for you compared to in GCP. When you go to add a credential, you are presented with this view. You have a drop down where there's like a bunch of like semi-pre-configured thingies, among others GitHub Actions. And what that does then is it prompts you for a couple of values. So it asks for what's the organization you're coming from, what's the repository you're coming from, and then it asks for this entity type, which is going to be one of environment, branch, pull request, or tag. I'm fitting tag as branch. So the way this looks, when I fill in these values, then that grayed out value at the bottom is going to be auto filled in for me with this is what the subject claim should look like for these values. So here I've filled in the pull request claim, and this has auto-completed for me to repo NDC Security demo /hello public pull request. And what this means now is if there comes an ID token from GitHub workflows with this exact sub, then yes, you get access to my resource. Okay, we need to do a demo now so you see how any of this actually works, because it's awfully confusing. Let's see if we have it. Yes. No, yes. Oh, right, it's playing in the background, is it? Excellent. Right, so this is the Azure UI. I have browsed to an app, or an app registration in this case. In the sidebar, I've gone to Manage, Certificates and Secrets, Federated Credentials. And if I actually do something here, let's see what's happening. What am I doing? Right, we are navigating. Yep, here we have a credential configured. This is the values I just showed in the slide, I'm pretty sure. Moving on, let's see what we can do with this. Right, yes. Let's see. Right, so here I am now an attacker. There's an existing workflow here which makes use of this federated credential. So you can see here this, can we see here? You have this action here named Azure Login. So that's helpers for you to do this actual like token exchange business, which is why I just didn't speak about how that happens in OIDC. I just give this some like values for what resource in Azure I'm trying to impersonate. And then this will do the whole OIDC flow for me. And then afterwards, I'm now authenticated to Azure. And I can, for example, use the Azure CLI, so that bottom command AZ account list is doing stuff in Azure. As an attacker now, let's see what we plan on doing. riveting. Here we are. Right, so I've gone and modified this workflow in a couple of places. I have, at the bottom, I've added a command to exfiltrate the Azure token. So I can execute Azure commands directly here in my workflow. I'm authenticated. It's probably stealthier to just take out the token and do them from somewhere else. I've also modified the condition on when this triggers and said that trigger this when I make a pull request to the dummy branch, not to the main branch. I want to stay off it. And then what I'm going to do is go and make a pull request with this code. I'm going to make a pull request from the secret hacker branch, which is what I just committed to the dummy branch. So a side note here is that I could also do this as a draft pull request. In this case, I haven't paid, so I can't do it as a draft pull request, but pretend like I did. We make a pull request. This is going to trigger the workflow to run. And we can here see this logging process via OIDC. So this helpfully prints various stuff for us. So it tells you the subject claim, which is going to be used. This is what I'm sending to Azure. So it's sending exactly this repo, NDC Security demo, hello world, pull request. It says that this was successful, and then afterwards I'm exfiltrating my token here so we can see that run to the end. I don't think I actually do anything with the token, but it's always exciting. So we got an access token. Ooh, that's not what I'm trying to do. Access token, which I can now go and use with various Azure APIs. I'll have to exchange it for something else, but it's kind of the high level here is I've stolen the Azure token. Now, it's probably not that shocking that I could do that, because, again, collaborators can do what they want. But what might be surprising is that this pull request entity type, as they call it in Azure, just has no inherent protections. Right? It can be a pull request from anywhere to anywhere. It can be a draft pull request. Like, there's absolutely no restrictions. So let's bring out the warning again. Security-wise, I didn't know how to write this in a snappy way. If you use this pre-suggested pull request thingy, from a security point of view, you might as well have just ignored the last part and said just anything coming from this repo and organization is allowed to access this credential. So this is a thing we see a lot in tests, like things scope to pull requests because Azure suggests it. So of course people will use it, and then you kind of just don't think that much more about it, and it turns out from a security point of view, this is really not secure at all. Okay, next let's summarize the Azure case. So the pull request subject identifier gives no protections. So if you use that, just know that that means you want anyone in the repo to be able to access this. If you use the ref or the environment versions, which was like assert on like you have the repo and then you have a matching environment or you have a matching ref, you can make this safe if you ensure that the matching resource in GitHub is safe. Right? So it doesn't help that I make a federated credential and I say this has to be in the prod environment if I have a prod environment set up in GitHub without any protections, because then I can do my same tricks again. So this we've also seen cases of at customers. Same with the branch case. Like, it doesn't help that I say this has to come from the main branch if anyone can commit code to the main branch, because then you just do that right. There's also an option to specify the subject identifier manually. So the grayed out box, you can press a thing and you get a warning, and then you can edit it directly. This is just back to the GCP case, right, where you do it manually. Lots of ways to screw up. We get back to that later. AWS, identity federation. Note how it's almost federated identities, but not quite. Keeping it interesting. OK, so what you do is you set up something called an identity. We've seen a lot, like, I'm not going to go into all these details again and again. The key part here is that in AWS, you are prompted to set up a GitHub organization. And then you are told to optionally also specify a repository and a branch. So it used to be that this asked for nothing, I think. It was wildly insecure by default. Now you can get away with at least specifying an organization. And what you'll see down there at the bottom right is that this has filled in that you have a subclaim, which is supposed to match the format repo, name of organization, / wildcard. Okay, so any repo in the organization can access this credential. Now, wildcards are always fun as attackers. You are allowed to do whatever you want here, right? Like, you could literally do repo : and say this identity can be accessed by anyone from GitHub. As long as you have a GitHub token, it's going to be approved for this policy, sorry, it's called in AWS, I think. Access policy, maybe. Probably you aren't going to go in and do that without knowing what that means. You have to manually go and set that to be repo *. Just don't do it, I guess. But something which could happen more realistically is that I meant to say, do you know what, this isn't that sensitive, anyone in the organization can run it, so let's just do repo :NDC Security demo and then a wildcard, and then I forget the slash. So now I can make my own organization named NDC Security demos, and that can go and access my credentials, right? So you can mess up really easily with wildcards. My philosophy here is that since you are allowed to assert on any claim you want in AWS, you don't have to use the subclaim. So if you meant to just use the organization name, just use that claim instead. There's a claim which is called repository owner, which gives you exactly the organization name. Use that if that's what you meant to use, kind of thing. Summarizing, you can assert on any value of any claim, including wildcard matches, that's fun. There's lots of ways to screw up, more on that now, because we've covered the 3 major providers. Okay, so what's a safe claim to assert on? First of all, if I'm asserting on sub, which is what all documentation always tells you to do in GitHub, this is only going to be as safe as whatever GitHub setup you have. So I did comment on this a bit earlier as well, but if I'm gonna assert on you are on the right branch, I better make sure that the right branch is protected, right? Similar for environments, pull request isn't protected. You can put in all kinds of nonsense here which isn't protected. Just be aware of that. What is this subclaim, actually? So it is this weird thingy where you've just concatenated together a bunch of other claims, like the repo or the branch or the environment, or there's super many other options here. And you can actually go in GitHub and configure this to be whatever you want. So typically, we don't see that people go in and start modeling with this in GitHub. I think this is more relevant for other other CI/CD systems. I don't know any off the top of my head which make you configure this completely. But if you go in and start meddling with this, then you can mess up really, really badly. So let's say I configure my GitHub subclaim to be one of the following things. So I mean, these are examples. These are like the value you get in a concrete case. For the first one, I've configured it to only send the branch you own, only the reference. This is, of course, a disaster because you have a main branch in any repository, right? So you aren't tied in any way here to a repo or an org. In the second case, line 2, I decided I'm going to now bring in the workflow name, which is this workflow :. First of all, the workflow name is in no way secure because that's in control. The person who controls the workflow file controls the name, so don't use that to begin with. Also, if you're going to use it, don't put the claims in this order. Because what I can do here is I can go in any old repository and make a workflow with the following name. So my workflow is named deploy AWS, repo NDC Security demo, blah, blah, blah. And then in this malicious repo, I just configure that sub token to only have this claim. And now it will match the one I configured in the other one because sub matching is only done like, it's a literal string comparison. There's no structure to this for some reason. The third one has a similar problem. So as a baseline, doing repo plus environment should be safe if you have your environment set up properly. If you mess up the order, so you've got to manually set, I want my subclaim to include environment and I want it to include repo. If you mess up the ordering of that, then we get exactly the same problem again. So I can go make an environment named prod : repo NDC security, blah, 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 blah. And you have a bunch of problems like this. So whenever you start setting up this subclaim manually, you have to be very careful about what you are doing. You can do all of these attacks from any repo org. So I have not seen anyone do this in real life. This is just my examples, by the way. The other stuff we actually see at customers, no one's stupid enough to do this in GitHub, I hope. OK. There's one more topic I want to talk about. And this is taken from the GitHub security hardening docs. So this is under GitHub Actions. What can I do if I really want to be careful here? And there's one thing they mention, which is that you isolate critical workflows. We've seen time and time again that I can, as the Collaborator attacker, I can keep modifying the workflows, right? So you can never do any sort of protections in the workflow files themselves. However, what if I put my sensitive workflows in a separate repository? And this repository has really hardened access. So there's 2 people in my organization who can write that. We have the workflow set up in such a way that there's enough input and config and stuff you send into it that we basically never need to change them. They just are there and exist. No one ever goes and modifies them. We are finally secure. We can have a check in our workflow. So here's an example of how you would call a workflow from a different repository. You probably cannot read that. It just says users. And then it's a long, long, long path, which gives you organization, repo, path within the repo to a YAML file, like the workflow file, and then it gives you like an @ and then you can specify in some way which version of the file you want. So for example, here I've used @main to say, take the version from the main branch in that repository. What you should do here is you should pin it to a commit hash, so you should do @hash. This was already too long and too small, so I didn't do that in this case. But pretend like we did the secure thing and used the hash here. Or not, I don't know, we're hacking it, so maybe don't do the secure thing. Okay. What is it I want to say? Right, so we've configured this separate repository with workflows. Now, with our existing setups with these like federated identity thingies, we still haven't got any extra protections, because I have no idea if you're using my secure workflow or not. You might still just be running your good old hacker-controlled code. But what you can do, now we get into customizing what GitHub sends, you can set it up to include a claim, which is called job workflow ref, which gives you the reference to which workflow am I currently actually running in. So when I, from workflow number 1 in my repository where I have Collaborator access, call out to workflow number 2, which I only have read access to, when I'm over here, then the value of the job workflow ref is going to be pointing to this workflow file, not this one. So if I send that with, then when you are specifically in the safe workflow, you are now allowed to access this resource kind of thing. So here's an example claim. You can see these things get really, really nasty. You have to set up this string like manually, literally, again, spell out the string. As a side note, you can imagine a case here where I try to set this up and I put a typo in like the repo name or something, and then suddenly someone else can go and claim that repo and I'm hacked. Very strange that everything has just happened on like literal string matching. No structure, there is structure here, okay, but yes. Right, so the example claim, we have the repo part that we've been seeing all along. And then as the second part, we have this wonderful job workflow ref claim. Again, you probably can't read the whole thing, but this gives you like the whole path to the workflow file I've referenced. So within a repository, and then it gives you, again, an @ and then, in this case, a branch, because that's the way I set it up. So if I attempt to bypass this, so in the top lines of this slide, I'm using the like safe workflow. When I do that, it's going to be able to authenticate to Azure. Life is going to be good. And I'm like, right. I know how to do this now. I'm going to log into Azure directly. I'm going to steal the secrets. I've done this 10 times already. No problem. But when I try to run this, I get an error on the step where I authenticate to Azure because my claim is wrong. So what's happened here is that this wonderful job workflow ref, when I'm in my workflow file, has been set to that path, not the one I'm calling out to. It's only the code in the other one which is has the right job workflow ref. So this really does work the way you want it to do from a security perspective. When you read about this, this might sound like feel warm and fuzzy. I'm like, okay, that is a way where I can have a safe workflow file. Finally, that's great. But is it safe? Okay, the attacker, we cannot modify the reusable workflow, but can I control what it's doing? So now we are actually going to loop back around to the first vulnerability we saw today, which was script injection. Let's say the reusable workflow has script injection. Now, suddenly, again, I can control what it's doing, and I can start exfiltrating secrets and stuff in the secure part of the workflow. Or, what's more likely is that your workflow is doing something with my code, right? Otherwise, why am I using it? Like, it doesn't need to have anything to do with my repo, unless it's actually using something from my repo. And maybe something I'm doing in my repo is going to be used in an unsafe way over there and allow me to execute code or something. So we have an example of that, which we've seen at several different customers, which is, let's see. Oh, right, I keep running in the background. Stop. Let's try again. Okay, so what we have here is the, we have an existing workflow which calls one of these reusable workflows. You pass in all your like Azure ID thingies, like telling this is the Azure app we are going to impersonate, and then that reusable workflow, which is now called reusable Terraform, so you can guess what it's going to do, it's going to do some Terraform commands for you. I think we'll get to see it in a second. Let's see. Yeah, so now we are in the, I'm zoomed in too far, but now we are in the reusable one. And what happens here is that we run a bunch of, we do an Azure login, we do some Terraform setup, and then we run Terraform plan. And then here we have this check that if the branch is the main branch, then you're allowed to do Terraform apply. Now this check I cannot just bypass, because this is code I don't control anymore. The problem is I'm running Terraform plan. Terraform plan can actually execute code. So what I can do is, as an attacker, I'm at like a million speed, that's why this is going so fast. Let's go a tiny bit back. As an attacker, I can just make some Terraform code which will execute at plan time, I like to call it. In this case, I'm not actually executing code, I'm just reading a file, because that's even easier. So I'm going to go and read this Azure token cache, because the Azure login was done before the Terraform apply, because otherwise it can't see what's going to happen with the Azure resources it's affecting. I'm going to just go and read this in the Terraform plan stage, and if we let this run to completion, I'm going to commit this, I'm going to make a pull request, it's hopefully going to trigger my workflow. This is going to run, it's going to succeed, so we can again pause here and zoom in on the subject claim. You can see these are really, really nasty things these days. We are in the reusable workflow, because now it's doing Terraform plan in the context of the reusable one. Moving along, we do Terraform init, and Terraform plan has now printed my access token. Okay, great. So we bypassed this whole stupid reusable workflow stuff. This is like a tale of caution, because just because the workflow file is safe, there's like a million different ways you can mess this up and give people some kind of control of what's happening in the workflow. So be very, very sure that you have no code execution from the person who uses your workflow. So that could be Terraform, is an example, like I said, we've seen multiple places. You can have like some kind of infrastructure's code stuff, often has some way to read a file or execute code. And I'm sure there's many other examples too. All right, we are nearing lunch. Let's do a summary. We have time for that, don't we? Yes. All right, so in terms of pure GitHub config, first of all, don't put your security measures, which are supposed to protect against collaborators, within workflow files themselves. If you do, put them in a separate repo and be very careful. But yeah, let's not talk about that. Use branch protections. So like your main branch or whatever should have all these checks in place. Use environments and tie the environments to protected branches to make them protected. Always put your secrets in the environment, unless they aren't actually that secret, in which case do whatever you want. I guess it's a secret at that point. And avoid script injections by always using this env thingy inside the steps in your workflows. Easy. Your OIDC config in the cloud. I'm going to state don't use wildcards. I'm sure there are legitimate use cases to use wildcards, but you'll know, like, you've looked at this closely enough to know you need a wildcard. You probably know what you're doing. Is that generally true? I'm not sure. Okay. Ensure that the GitHub subclaim, which you've configured to send out, so like the default one was the like repo and either environment branch or pull request. If you're going to modify this, you better make sure that it's using safe values in a safe order. When you assert on the sub, be as specific as you can. So again, like if you can be more specific than just the organization, be more specific than just the organization. And then if your cloud identity thingy, if you want some kind of protections on that, then you better make sure that your sub is tied to a protected thing. So if you're going to assert on the ref, make sure it is referencing a protected branch. If you're going to do an environment, it has to reference a protected environment. If it's going to do the like workflow in another repository thing, make sure to mention both the repository you're currently running in and the one you're referencing. And finally, and this is, to be honest, I mean, completely out of place on this slide, follow the principle of least privilege, but that's actually the thing which customers mess up the most on our tests. So we have all these ways to get your Azure credentials or whatever. This doesn't really need to be a huge problem, right? It might be that they are scoped exactly right, so they can only do exactly what the workflow was doing, and I was supposed to be able to run the workflow and do that thing. What happens in real life is someone has just given a way too wide permission, right? So by taking over some service principal, I can now do everything in your Azure cloud, for example. So this is like the main one, is even just because I've configured my credential in some way to be tied to a workflow, the workflow is doing 3 or 4 things, the remaining permissions can still be used, right? People can still go in and modify this and do whatever else. And that's it. Thank you very much. I took the liberty of modifying the binary security logo to match NDC, so that's me. All right, I guess we have a few minutes for questions, if anyone has any. Yes?
In your last demo, what caused the Terraform plan to execute a malicious file that you need?
Right, so that is, let's see if we find it. Here somewhere. So that is the following. So I'm in a Terraform file, and this is like a legitimate thing you can do in Terraform is to use this file thingy. I've forgotten the proper names in Terraform.
I get that, but this is a file in your the current repository.
Yeah, this is in my repository. Right, so the point of the reusable workflow is to do like a safe Terraform apply, really. So it's applying the code in your, like in other repositories. So every repository should use this one to do Terraform plan. And then this workflow should ensure that you only do that from the main branch in all the other repositories. So it's still a code from the other repository you are applying to different places, or planning, or yeah. Yes?
Well, there's a really nice tool to do these types of checkings in workflows called Zsmore. I don't know if you ever heard about it.
What did you call it, sorry?
It's called Zsmore.
I haven't heard of this, no.
It's a tool that goes to your workflows and checks for potential vulnerabilities that you do on your workflow. For instance, the cases that you mentioned about the injection,
Yeah.
they are all pointed by the tool.
Yes, yeah. Yeah, I've seen other tools which point out this injection thing as well. That's beginning to be a very well-known thing. Somehow it still happens, though. Yeah.
The ones that you mentioned now in Terraform.
Right, exactly, yeah.
And the question is, have you done something with the GitHub token that is generated for the workflow?
Yes, so I chose to, I mean, there's way too many things to cover, right? I've only scratched the surface. So the GitHub token I chose to completely ignore because that's a whole other thing. I guess we could have a separate talk on what kind of permissions you have there. In all of these, if you are going to do the OIDC thing, you must have given it the like token permission, right? Of course, if you don't have that, you can't go in and start stealing cloud credentials, but I've kind of chosen to gloss over that entirely. Right, any other questions, or shall we go eat? One more question.
Please show the QR code for the slides again.
Sure. Oh yeah, there's also some references at the end, but you can take them from here. Ah, so you trust me now. But not at the start. That's interesting. Excellent. Okay, I guess let's go eat. Thank you very much.